All right, let's talk about something so fundamental to our lives we barely even think about it. The difference between analog and digital. What do these terms actually mean? And, more importantly, how did one of them completely take over our world? So, to get our heads around this, let me start with a simple question. I want you to think about your phone, your computer, your TV. Is the information flowing through it more like a smooth, continuous ramp? Or is it more like a set of distinct, separate steps on a staircase? Well, the answer is the staircase. And believe it or not, this one little visual, it's the key to understanding everything. See, an analog signal is the ramp. It's totally continuous. You can be at any point along its slope. But a digital signal? That's the staircase. It's made of separate, distinct steps. You're either on step 1 or you're on step 2. There is nothing in between. We're going to keep coming back to this idea.
Okay, so let's dig into that ramp first. What does it really mean for a signal to be analog, to be a mirror image of the worlds around us?
You know, the word analog itself is a huge clue. It's an analogy for the real thing. When you speak into a microphone, you create this complex, continuous sound wave in the air. An analog recording, like on a vinyl record, carves a physical groove that is a direct, continuous copy, literally a mirror image of that original sound wave. And that's why you'll often hear people say that nature is analog. Think about it. The sound of your voice, the way sunlight fades at dusk, the smooth, unbroken sweep of an old clock's second hand, it's all continuous. This is the world of old landline phones, AM/FM radio, and that familiar hiss you'd hear on a cassette tape. It's all part of that analog world. But, and this is a big but, analog has a huge weakness, a fatal flaw, really, that's perfectly captured by this idea. Analog systems amplify noise right along with the signal. They just can't tell the difference between what's supposed to be there and what isn't. And the scratched record problem is the perfect way to picture this. When the needle on a record player hits a tiny scratch in the vinyl, it has no idea that that pop sound isn't part of the song. It just reads the groove exactly as it is. The music, the scratch, all of it. That noise gets mixed right in and becomes a permanent part of the signal.
So, if the analog ramp has this massive noise problem, what's the other option? Well, let's go back to our staircase and step into the world of digital.
See, digital communication does something completely different, and it's so clever. Instead of trying to send a perfect, fragile copy of the original wave, it just measures the wave at thousands of points per second. Then, it converts each of those measurements into a simple code of ones and zeros. It's not sending the thing itself, it's sending a super detailed, coded description of the thing.
This next analogy really drives home just how powerful that code is. Imagine you need to tell your friend, who's a kilometer away, exactly how much water is in a tank. The analog way would be to carry a bucket with that exact amount of water. But what happens if you trip and spill some? The digital way, you just measure the water, write 5 liters on a piece of paper, and send the note over.
And this is the magic trick of digital. Even if that piece of paper gets crumpled, smudged, or a little rained on, as long as your friend can still read the number 5, the information arrives perfectly intact. The system is designed to ignore the crumpled paper, the noise, and just read the all-important code. All right, so we get the ramp and we get the staircase. Now let's put them in the ring together and see what happens in a real practical showdown. This might just be the most mind-blowing difference between the two: making copies. If you take an old cassette tape and make a copy of it, and then make a copy of that copy, and so on, by the time you get to the 10th copy, it's just a mess of hiss and warbled noise. But a digital file, you can copy it 1,000,000 times or 1,000,000,000 times, and the 1,000,000th copy is a perfect, bit-for-bit, absolutely identical clone of the original. So let's just pull this all together and look at the key differences side by side. It all comes back to the signal type, right? The analog continuous wave is super vulnerable to noise, but the digital code of ones and zeros, it's incredibly tough and resistant to noise. And that incredible resistance is what makes digital so easy to store in huge amounts on tiny devices and so easy to secure with encryption. Okay, so that's the tech. But why should you care? Why does any of this matter? I mean, how did we end up in a world that is so completely dominated by the staircase? In short, why did digital win? Well, the advantages are they're overwhelming. Digital gives us perfect transmission, which lets us get crystal clear pictures from probes on Mars. It allows for massive compact storage. Think about it, thousands of songs in your pocket. Because it's a code, computers can easily process it, letting us edit photos, stream movies, and compress files. And maybe most importantly, it allows for the encryption that secures everything from our private messages to our online banking. So let's wrap this up with one last, really elegant analogy that I think sums it all up beautifully. Analog is like drawing with a pencil. It's smooth, it's continuous, it has infinite nuance and subtlety. But if you smudge the page or make a mistake, that error becomes a permanent part of the drawing. Digital, on the other hand, is like typing on a keyboard. It's exact, it's precise, and if you make a typo, you just hit backspace and correct it perfectly. So here we are. We've built our entire modern world on the precision of that staircase, on these discrete ones and zeros. But the universe we are trying to describe, our voices, the light around us, the world itself, that's all still the continuous analog ramp. Which leaves us with one last big question to chew on. When we convert that infinitely complex ramp into a finite set of steps, what, if anything,